South Australia has an extraordinary fossil heritage, and here's the thing, if you want to get up and close and personal to the fossils that make up that heritage, there are plenty of opportunities to do so. There's no better place in Adelaide to visit than the South Australian Museum, to walk through its remarkable fossil galleries and know that you are travelling more than 500 million years through the history of life. Or you can head to the World Heritage Naracoorte Caves, where thousands of prehistoric marvels are laid to rest in a place of wonder and adventure. Travel to Kuba Pedy, once at the bottom of the sea, where some of the world's most extraordinary opalized fossils have been found. Or the Flinders Ranges, where you can experience the marvel of the first complex life on Earth. And while you're in the neighbourhood, further north to the geological wonderland of Akarula. And of course there's Kangaroo Island, an island of incredible natural history wonders, home to one of the world's first great predators. For we who live in South Australia, these places matter. All of them are central to the story of who we are. And if you're based here, now is the time to explore Adelaide and the regions and discover more about our fossils, our stories, our heritage. Now let's head to the stage. I'll see you there.
Well. Thank you to our four speakers for their wonderful talks before. I have here a T-Rex claw, and I have it here because I always like to start the conversation. When we talk about paleontology and Dinosaur University, we often go to dinosaurs and we often go to T-Rex because, let's face it, it is a pretty awesome prehistoric animal and the most famous of all. But they don't come from South Australia. And here in South Australia, we have our own unique and extraordinary fossil heritage that we've talked about, that we've heard about, that we've sung about. So with our four speakers, we're going to have a bit of a chat. They've got no idea what I'm going to ask them, and we'll see how we go from there. So, Mike, where are all the dinosaurs? Why don't we find dinosaurs here in South Australia?
We do have small fragments of dinosaurs, but you're right, we don't have very many dinosaur skeletons. And the reason for that, as you would have heard from my talk, is that South Australia was underwater for most of the Cretaceous. So the animals we find, the big reptiles we find are things like plesiosaurs and ichthyosaurs and turtles, which I think are every bit as awesome as dinosaurs.
Absolutely, and as the song goes, I'm not a dinosaur, because people often think of plesiosaurs as dinosaurs. They're marine reptiles, yes, but they're not dinosaurs. So I want to ask each of you, because you're here as paleontologists here in South Australia, and as a paleontologist, you could be anywhere, couldn't you? We find fossils on all of the continents. So, Felicity, start with you. We'll go randomly, perhaps. Felicity, why South Australia? What is it about here? Why are you not overseas?
Oh, well, I love South Australia, for one. I love living here, but also it's got some of the best fossil assemblages of Ediacaran fossils. So in the Flinders Ranges, as you would have heard through my talk, we've got some of the most diverse types of fossils, some of the most diverse taxa. We've got some of the earliest types of Ediacaran fossils that actually resemble animals, and it's so accessible. And it's just, it's a no-brainer.
And it's the best example in the world, isn't it? It's even named after the Ediacaran Hills.
Yeah,
and it's the only time period, and this is the thing to remember, here in South Australia, the only time period named after something in the southern hemisphere. And it's named after the hills because of the importance of that heritage.
Yes.
And our state fossil emblem here in South Australia is Spragina, and there's some suggestion...
It's an Ediacaran fossil.
It's an Ediacaran fossil. And there's some suggestion that maybe it's the first animal with a head and maybe a brain. So maybe... Diego, you've studied Ediacarans. And you're not from South Australia, but you've come here to study Ediacarans, but also the Cambrians. Do brains come from South Australia? Can we say that? Can we say that to our friends?
Well, I would hope so. What happens with the Spragina, and it's a group of fossils, the Ediacarans, that I've looked into for the last few years, and the reason to come into South Australia is because it's basically the best place in the planet to look at just before and just after the Cambrian explosion. So the before, it's the animals that Felicity was talking about, and the after are the ones that I was talking about, and basically that's where animal life explodes in the planet. And whether Sprigina does have a brain, or maybe more than a brain, sensors in the anterior part of their body,
Because it's
that
something
is
before a brain, isn't it? Before it becomes a brain like we've got,
Yeah.
it goes through a few steps.
it's the, sort of the hard drive of the organism. It's where it gets all the information, processes that information, and then acts upon it, whether it has to swim away or crawl away or burrow. So that's where all the sensors are and where all the signals are processed.
And so for you, bringing your family from Spain, you came all this way to study the Cambrian and the Ediacarans, and you talked about Anomalocaris,
Yes.
like one of the first great predators in the world.
Absolutely. Well, if as we were talking earlier, it's what you're looking at is something that it's a quantum leap from the stromatolites that we had before, those first billion years of our Earth's planet, history. And we're looking at something a lot more complex than that. And the fossil record is what gives us information about this. And there are some localities like the ones in the Ediacaran and other places, Canada, etc., some localities like the Burgess Shale that also has Cambrian fossils of a lot of information. But that is where you get most of what you need to ask. All the big questions, you can pose them in places like South Australia, and you cannot do that in anywhere else in any of the other states of South Australian states.
And as we're talking, probably the best place in the world. And so while we don't have the dinosaurs, we've got all this other stuff. Now, Diana, you're a paleontologist at Flinders University. What is it? I mean, you mentioned the floof.
Yes.
Right, the floof. And we know. We've got floof. One of the things that I love, is that I can now buy a toy Diprotodon. Like you can, for a long time, if I wanted a prehistoric animal from the Cenozoic, I had to get like a woolly mammoth or something. Whereas I can now get a Diprotodon, or maybe if Diego wants to hand over his Anomalocaris toy, I can get that as well. But what is it about the floof that resonates with us, and why here?
Well, like the other said, South Australia has obviously just got such a great fossil record. So why would you want to go anywhere else to study fossils? And also there's so much paleontology work being done in South Australia. I mean, you know, we've got the paleo crew at Flinders and we've got the paleo crew at Adelaide. So that's where the research is happening. And as far as floof goes, well, I mean, why wouldn't you like floof? You know, it's warm.
It's warm
not,
and fluffy and
you know,
cuddly, and you can yellow little floofy things.
It's not kind of, you know, it's not squishy and slimy. It's not
like,
hard trilobites,
like
and
the
it's not
reptilian
scary.
things. It's not scary. It's not going to
it's
eat
adorable.
you. Oh no, Thylacoleo is going to eat you.
Oh, okay, yeah.
Rock bear's
I'll
going
give
to
you
eat
that.
you. Okay, so a couple of months ago, I went through this process of thinking, like, let's get some paleontologists together, and I asked you all, and you all said yes. So, to you, Mike, why did you say yes to talk today? What was it? For you?
Well, science now is more than just sitting in a dusty lab looking at your fossils. It's going out, telling people about your research, engaging and making a difference. And that's what we're doing today. And that's what we hope to continue doing.
Absolutely. And Felicity, what made you say yes? Was it because you have a little one and they want to sing Professor Flint songs? That was it, wasn't
no, that's
it?
part of it. Yeah,
That's part of it,
yeah.
So what was it for you?
No, I largely agree with Mike too. You know, like it's all about educating people about science and biology and geology and our rich history on Earth, and how I guess I'm a firm believer that we're not like these grand results of evolution, us humans. You know, there's this huge prehistory to us. There's more than just us on this planet, and it's awesome.
I think the reason why I said yes is because we want to make South Australian, especially the younger generations, aware that they have an outstanding heritage. They should be proud of what they have. These are some of the best fossils in the planet, whether it be opalized or the Megafauna, which was here until the day before yesterday, Ediacarans or Cambrians. All those regions have to be proud of what they have, whether it be KI or the southeast or the Flinders Ranges or Kubapiti. These are amazing fossils, and every South Australian should know that we have this. And it's at no level less than, you know, the T-Rex in North America or the ichthyosaurs that they have in the UK, for instance.
And one of the cool things, isn't it? And one of the things I like to talk about is that there are fossils, there are stories, and they're our heritage. And I think we have so many good stories to tell. and the amount of work that's being done at Adelaide University and Flinders University, and a little bit at Dinosaur University, of course. I mean, we're here, based in Adelaide, but we don't have many dinosaurs. But dinosaurs don't make sense unless you know about all the other things. So, Mike, no, I asked you before, didn't I? Yes, why did you say yes? No, you said yes. Did I ask you?
No.
No, you didn't.
No, I haven't asked you. Why did you say yes? Did I just cajole you?
No, you did ask me why I said yes, and I told you we need to.
Oh, yes. It's
There we go.
Flint. It's
Yeah,
the Flint
yeah.
Queen. Okay, so Diana, what was it about you that eventually made you say, yeah, absolutely, I want to chat?
Well, I think the Cenozoic's amazing, and so I really like the opportunity to get out there and tell more people about it. And someone had to represent the floof.
Exactly. Okay, so one of the questions we're always asked, and paleontologists are always asked, is like, what got you into doing this? And also, not just what was the motivation, right, I want to be a paleontologist when I grow up, if it was that, but also how did you then get to be a paleontologist? Maybe start with you, Mike.
Yes, well, when I was in primary school, paleontology probably wasn't on the radar. I was really interested in reptiles. And every lunch hour, while all the cool kids were playing cricket and doing sports, we'd run around the back of the school catching lizards. And Harry Butler at the time was on TV, and he was sort of, the Steve Irwin of his day. And he pretty much set me on my course to becoming a naturalist. But so I did zoology at the University of Queensland, and my initial ambition was to be a marine biologist. But it turned out I get really, really, really terrible seasickness. So that was off the radar.
That's prepared to that.
Yeah,
but
yeah.
that then presents itself an
Yes.
opportunity, doesn't it?
It did.
It's
So
like,
I had
well,
to
like-
switch to something more land-based. And by the way, I'm in great company. I mean, if you read Charles Darwin's biographies, he was a famous kind of, green seasickness person.
Oh, well, of course.
Yeah.
Yes.
But I don't think I'm anywhere near that. But so yeah, I had to become mumuch more land-based in my research and in my aspirations.
And then from there, one thing led to
another.
another. So, Diana, what about you? What was it? Was it because we often find there's a love of nature, and I think it's really important to if you're wanting to learn to be a paleontologist, part of becoming one is to observe nature, to watch it, to have a journal, to go into the garden, to watch the nature in the garden, all those sorts of things. What was it that brought you to the paleontological table?
Well, I wasn't one of these kids who really likes dinosaurs. I was more of a... No, I mean, I like them, but, I was more into, I guess, just natural history in general. And I went to uni thinking I was going to become a conservationist. And then I found paleontology, and I realised that paleontology and conservation are so intertwined, especially when you're working in Cenozoic. So I did a degree at Flinders, and here I am.
And here you are. Here you are. Now, Diego, I haven't asked you, have I?
No.
So,
Well, my
were you the
parents-
dinosaur kid?
No.
Were
by
any
no
of you the
means.
dinosaur
No,
kid?
Sorry. I mean,
No,
yeah,
I
was
think
curious
this is
about them.
really important because often people think, well, you have to be, you have
Dinosaur
to
lover too.
the dinosaur lover to begin with, but sometimes different doors open and different doors close, and then
Many paths.
many paths to get there. So yes.
So
your story.
in my case, well, both my parents are biologists, but they work with Drosophila, with the development of animals and understanding how animals are formed. And my grandfather was an archaeologist, so I think I kind of mixed both things, digging things up, and I've always liked, digging and finding rocks that could be, an axe or something. And then I went to university. I did my degree in Madrid, biology, and within biology, zoology. And when I realized the amazing diversity of animal life today, all the marine phyla, and there's 35 phyla. We mostly just talk about vertebrates or mollusk or arthropods, but there's dozens more. And that gave me the ideas like, wow, there must have been something amazing at the beginning of this. And then I started looking into early animal evolution and how those groups are related to each other, which came first, what sort of pressures were there, evolutionary pressures that is, in the diversity, and how did those shapes and forms arise. So I'm a biologist. I love bird watching. I love being outdoors. I love checking out trees and seeing what sort of species it is, etc. But I wasn't, from my start, I wasn't a particular growing up collecting fossils everywhere. I was collecting rocks and fossils and mushrooms and not magic ones, but all the others.
Of course, of course. So, why does paleontology matter as a science? I mean, I think it should be taught in all schools, and I'll answer it first, right? So I'll ask the question, and I'm answering it first. I think, and I think it matters because the story, and I say it a lot, the story of where you live, the fossils, the things, the animals that walked or swam or flew, where you live, are part of the story of you, aren't they? Wherever you are in the world, I think it's so important to learn all of the stories of all of of what came before you. One of the great privileges that I've had is in working with some local Ghana elders, and what they taught me was the importance of connecting to place, the importance of learning about ancestors, the importance of listening to the shadows of the prehistoric past, so to speak, and understanding all of those things. So, who wants to go first as to why? Maybe Diana, because you kind of touched on it in your talk, didn't you? When you talked about climate, changing climates and things, and the practical possibilities of what we might learn. Is that a reason why it matters?
That's, I think, one of the reasons for sure. I mean, we can't really understand the present or the future unless we understand the past first, really. And paleontology is not just about, looking at bones and stuff. I mean, if it wasn't for paleontology, how much longer would it have taken Darwin, to come through with theory of natural selection, etc.?
That's right. If it wasn't for people like Mary Anning before him.
yeah.
Aye, absolutely. Cool. So, Mike, why do you think paleontology matters?
Yeah, I've got a long double-barreled answer to this.
Oh,
so
good.
how long are we on there for?
We've got. Oh, no. That's it. No,
okay, thank you.
No, please go.
Yes,
go.
well, I mean, the first and the most obvious thing is paleontology tells you how the biodiversity of the world has changed as the world has changed. And that can be no more relevant today than at any other time. But the other thing about paleontology is that it's not always a blue sky kind of type of research program where you're just looking at an abstract scientific problem with no practical applications. It actually can contribute directly to humanity. And the most famous example of that is paleontology's contribution to world peace. And absolutely.
Who knew
Yeah,
paleontology
exactly.
brought world peace at last?
Yeah, what actually happened was that the paleontologists who were trying to work out how the dinosaurs died worked out that a meteorite probably hit the Earth and threw up a dust cloud that blocked out the sun. And the modelers that did that spoke to Carl Sagan, the famous scientist and outreach person and media celebrity, who realized straight away that that a nuclear war would have exactly the same effect as a meteorite strike. And in that way, the concept of nuclear winter was born. So one of the key concepts that led to nuclear disarmament and the end of the Cold War came about directly from research on dinosaurs.
So through understanding paleontology, we were able to understand the consequences of something like an asteroid strike and its equivalence to a nuclear war.
Yep.
Fantastic. Felicity, why do you think it matters?
Because I think it gives us more of a grounding of how we evolved, our history, human history, and it's just awesome learning about the evolution of animal life on Earth and life in general, and learning about deep time, so before animals evolved, and the microorganisms that existed before. That might tell us more about what we might find on other planets and how other planets might evolve as well, and their environments, and what kind of life we might expect to find on other planets. And so it's got extending repercussions as well. So it might, it's a very interesting science.
It's very much that idea of a search for meaning for us, isn't it? And of our place in the universe. And because we know if we, if you 4.5 billion years of life was from there to there, 4.5 billion years of planet Earth, life starts about here and humans turn up here, and all along, for most of this, it's tiny little microscopic life. Now, we think that perhaps most life, if there's life on other planets, and I suspect there would be, is likely to be that microscopic stuff. But also we see extremophiles and we see extreme kind of creatures. Diego, why does paleontology matter?
Well, I totally agree with what's been said before. I think we could add a more down-to-earth connection, which is paleontology can be a source of income for the regions. We've got a lot of people that want to visit. There's regional geotourism, there's museums, there's education. Paleontology can be what brings people closer to nature. I mean, yes, it's beautiful to be able to go out there with binoculars, but understanding how the Flinders Ranges got formed, why Wilpena Pound has got the Ediacaran fossils, and in the middle has got the Cambrian, sliver of Cambrian still there, understanding the granites that produced Victor Harbour, all those that are at the end of the Cambrian, etc. It is that connection to the land that you also touched upon. It's that feeling of country. It's that connection with the deep roots of our planet. And it's got some economical benefits as well in the form of geotourism. We should learn from that. We should also teach this in schools. I think all of what we've said tonight should be part of the curriculum, South Australian curriculum.
And the cool thing is here in South Australia, and wherever you are, do some research and find out what your local story is and where you can go. So, you can go to the South Australian Museum and you can see specimens, real specimens from all of these time periods.
And the Ediacarans one you can
and
touch.
The Ediacarans you can touch.
those.
You're touching animals that are 550 million years old. You can go to Kubapedi, you can go to Parachilna, you can go to Naracoorte, go to Kangaroo Island. Now is the time to be exploring these local places. Reach out to those local communities if you're in South Australia, and when borders close, come over. Check out the stories here. But while the borders are closed here in Australia, see what you can do to check out your own story. Okay, look, we've only got a few minutes left. I think we'll finish with, I want each of you to say something awesome about the time period that you didn't speak about. Felicity.
Okay, so I liked the Mesozoic because I think it gives you an understanding of these marine organisms, these marine animals that were living around the same time as the dinosaurs, but they don't get any spotlight, but they were there and they were very diverse and they were very interesting. So I thought that talk was great. By Mike, yep. So
Diego.
That's a difficult one. I think they're all so cool. I would probably have to say the Megafauna.
It's the floof, isn't it?
Yeah. There is something about it. I think that we've got so much to learn. So it's a window that's been closing. It's still closing. Unfortunately, we're losing elephants, we're losing rhinoceros, etc. We're losing the equivalent of what's been missing from around us for a while. But it's so close that you can still bring it back and learn from those mistakes. Things that we didn't know about ecology. We didn't know about all of those things 150, 1,000, 10,000 years ago. So we can't, blame it on anybody. That's just what humans do. But I think it's still close enough to actually learn some of those mistakes and try to fix them.
Mike.
Oh, I'll go back to Diego and I'll say I like the Cambrian because it's the most amazing period of biological evolution. I mean, virtually all the major groups of animals alive today, the insects, the crabs, the fish, the sea urchins, they all evolved in virtually the blink of an eye about 500 million years ago. And we still don't fully understand everything about that event.
And that's the cool thing, isn't it? People often expect us to know all the things, and we don't. And there were lots of gaps in our knowledge. We will never discover all of the dinosaurs that ever lived, all of the species, because not all of them will have fossilized. And even if they did, we wouldn't necessarily have found them. But Diana, okay, you pick one of the others.
Oh, that's hard. I think I'm going to have to go for the Cambrian. I mean, Anomalocaris, the first real apex predator. And why wouldn't you like Anomalocaris?
And it's fascinating, isn't it? Because once you have a predator...
oh, yeah, that's true.
Thank you.
There we go.
That's not supposed to happen. But the cool thing is, once you get a predator, then you get prey. And then you have a predator who has to be able to look and find and all of those sorts of things. Thank you so much for my four colleagues for joining me. Thank you to the Flintettes. Thank you to you for spending your time and sharing it with us here via the Ghostlight Bunker, as we call it, here in Adelaide on Ghana land. And I think I should stop talking now, and we're going to go. So thank you very much. You are awesome. Cheerio. Bye.